Ladies and gentlemen, today I'm going to present our sudden research entitled Bauxite Refinery Residue Neutralization Using Active Wet Carbonation Technique with me, Inggit Burisa, as your presenter today. I'm here as the representative or other contributed authors, Mr. Joko Wintoko and Mr. Agus Prasetya. We are from Chemical Engineering Department, Gadjah Mada University. Our presentation today consists of introduction, research methodology, result and discussion, and also conclusion. Let's start at introduction. Bauxite refinery residue, or well known as red mud, is a solid byproduct generated from bioprocess and alumina extraction from bauxite ore. With the characteristic of red mud itself, reddish color brown due to the presence of iron oxide, consists of mineral phase such as hematite, quartz, anastas, and so on, along with its heavy metal presence such as arsenic, cadmium, chromium, lead, and mercury. Due to the additions of caustic soda, made red mud is an alkaline material with pH range 10 to 13, and the presence of red mud itself in the nature is abundant. Per 1 ton aluminum product generated from 1 to 2 tons of discharged red mud. Then this going through land disposal without any further treatment and accumulate time to time. If this abundance and characteristic are not being handled well, we will face serious environmental problems. Carbon dioxide concentration at 2024 reached 425 ppm. Some experts predict this concentration will increase in the next year. If it keeps increasing, we will face catastrophic disaster. We need to mitigate further carbon dioxide release. Meanwhile, renewable energy transition are going to increase and slowly reduce carbon-based fuels. There are several ways to prevent carbon dioxide release. One of them is carbon capture storage, or CCS. Current status quo of Indonesia's CCS technology is using geological formations to store carbon dioxide, especially at depleted reservoir and saline aquifer. But we need to consider the leakage potential due to so many factors. So here we propose more stable carbon storage through carbonation sequestration using red mud. Previous study conducted showed that red mud has ability to sequestrate carbon, and carbon dioxide can reduce red mud high alkalinity. So we could utilize environmental threats as remedy for one and others. For Indonesia itself, utilization red mud as carbon sequestration need to be investigated further. So we are going to take part to investigate this potential at red mud originated from Indonesia. We come to research methodology. We use fresh red mud from Tabang Tayang, West Kalimantan, Indonesia. We also use laboratory equipment that have been written on the slide. And material characterization, we also utilize XRD for initial and final sample of red mud, and XRF to identify oxide phase contained in red mud. We also conducted our study at room temperature and atmospheric pressure, with fragment slurry contains 40% of solid content, and contacted by carbon dioxide gas at flow rate 5 liters per minute for 2 hours. After that, the treated sample is filtrated using vacuum filtration. Then further filtrate and residue analyzed using volumetric filtration and XRD analysis. This is our carbon sequestration process that will have been conducted at laboratory scale. Let's move into result and discussion. Can you see the initial sample characterization of this red mud? There are initial pH value, initial electrical conductivity value, water content, surface area, and hydrodynamic diameter. Let's talk about red mud composition itself. Generally contains oxides as it shows at the table, and the composition may vary from one place to others with weight-based range. But iron oxide still dominates the composition. As indicated at main constituents of Indonesia red mud from PT Indonesia Chemical Alumina, which was investigated by Dwi Melani et al. At 2023, dominated by iron oxide, followed by alumina and silica. So the composition of our sample used in the study. The neutralization effect of the red mud and carbon dioxide interaction itself from this graph shown that carbon dioxide has ability to neutralize red mud high alkalinity. The reaction occurred with instantaneously at first 20 minutes and can decrease from 11.25 to 7.52. Then the trend is stable for the next 20 and the next minutes until the neutralization process ended reach pH value 7.44. Hydroxide concentration will rapidly decreasing in line with the decrease of pH value. Dissolved carbon dioxide tend to be more alkaline than bicarbonate ions, but it less alkaline than hydroxyl ion. So at the first stage, carbon dioxide interacts with hydroxyl ion, then form bicarbonate. Excess bicarbonate will interact later, form carbonate 1. Carbonate ion is anion, and metal ion from red mud bulk is cation. Then the mineral phase carbonate is formed by those interactions. The mineral carbonate formation will lead to increasing electrical conductivity value, as we can see at the electrical conductivity value graph. At the first 5 minutes, the electrical conductivity decreased rapidly. This may happen because carbon dioxide and red mud constituent form compound that suppressed electrical conductivity value. After that, mineral carbonate form and electrical conductive value rebound slowly into higher at the end of the process. From XRD analysis, actually there's no significance of mineral phase between fresh red mud and neutralized red mud, but as you can see in detail, relative intensity of some mineral phase at neutralized red mud is higher than fresh red mud. For example, the most significant increasing of relative intensity at graphite mineral phase at angle 60 degree. From 19.8% in fresh red mud to 30.8% in neutralized red mud. The increasing of graphite intensity shows that the addition of carbon precipitated in red mud from mineral carbonate during neutralization process, since graphite in nature metamorphosed from limestones. The neutralization process of red mud is not only show its ability to decrease the high alkalinity of red mud, but also can form stable mineral carbonate. Based on the investigation of carbonate and bicarbonate analysis in aqueous phase, we can estimate carbon sequestration capacity equal to 1.4 gram carbon dioxide for each 100 gram of red mud. Here we come at the last part of our presentation today, conclusion. From this study, we can conclude that red mud slurry can be utilized using carbon dioxide gas, and then the reaction instantaneously happens at the first 20 minutes. Moreover, not only neutralization effect showed by this study, but also the formations of mineral carbonate deposited and residue of not neutralized red mud by increasing 11% relative intensity of graphite mineral phase at angle 60-degree peak. And from the filtrate, we can see the sequestration capacity 1.4 gram carbon dioxide for each 100 gram of red mud. That's all my presentation today. Thank you.